Welcome to a new test and teardown video. Look how big this is. I need to lift the phone all the way up in my face to take this picture. Oh, this is a big one. Look at that. So this is a Radiometer RV35 wideband millivolt meter. So you should work all the way from 10 hertz to 6 megahertz. You can of course go way higher, but then it's not going to be accurate. That is what they say in the manual. This design is made in 1964, and I think it is like 8 or 9 tubes in this one. This is high input impedance, 10 mega ohms, and I think it is in the higher ranges, right? There's something with the input impedance changes when you go from the lower to the higher. You can actually feel there's a special mechanical solution with the switches, so all those settings goes like really light. But hear this. Here, something special, and then easy. And then, so I believe there's something going on here in the middle, and like an extra switch or something. I can't wait to see what that is, but it's in beautiful condition. All I did was a little bit wash and clean, polish the front here a little bit. Look at that indicator, how beautiful that is. Let's look. Oh, this is heavy. Of course I can lift this, but oh my god, it is definitely heavy duty. So those are really nice for winding the cable for transport, and the fuse and the voltage indication. I believe this is the voltage output, so you can use this as an amplifier for something else, for measurements and whatnot. So that will be a DC voltage coming out here, amplified for the meter, and then you can use the settings and everything here for something else. The manual says 50 watts, right? So let's see if this thing uses 50 watts or whatever it does. So mains is applied, 223 volts, 80 watts, 62, 52, 40, and 36, 35. Okay, so watts. Oh, and now it's going up to 50 again, and 60. And okay, so that is a little bit funny. This looks exactly as what I would have expected. Hey, let's try some input. So this the readout here should be in volts RMS. So this is 1 volt full scale. Definitely. Let's try and give it some input. So let's start with 1 kilohertz, 1 volt RMS. And what do you know? This is very, very close. Let me try and turn off the output. And it's not going to 0. That is a little bit of a spooky thingy, because this meter was exactly at 0 when there was no power on. So why is that happening? It's because this input, look at that, is very, very high. And I believe when my signal generator here is turned off, this one goes open. So this is maybe hum from outer space we're reading here, right? But anyway, that is 1 volt. Let's go to 3. So this is that scale, and that is again 1. So let's go to 2 and 3. Okay, let's go to 10. So that will be that scale, right? So 10, and that is 3. Okay, 4, 5, 6, 7. Oops, I can only do 7. So it's reading a little bit on the low. What? I mean, let's go back to 1 volt RMS, and let's go back like this, and this is 1 kilohertz. So it says 10 hertz, right? Let's try 10 hertz. Ooh, isn't that cute? So that was 10. So it says 6 mega again. Okay, let's see, 6 mega. Oops, where's my signal? And that is probably because of the impedance, right? Okay, let's try 1 megahertz. Okay, full. So there is 1, 2, 3. Okay. I believe that has something to do with the loading here or something. I could have put a scope here and verified. Still had the voltage here. But it seems to be working. This is 1 megahertz. We could probably go like 100 kilohertz, and then it's really, really good. So that is a nice meter. And what you cannot see is how beautiful this looks. It is dark, dark blue and just really, really beautiful. And it's absolutely not at all what the camera sees here. Whoa, this lamp looks beautiful. But how about we look inside? That was not too difficult, just the 4 screws in the top. Oh, it is nice and warm from the 53 watts that it's using. See inside here the top lid, they removed the paint, and this is of course to give a good ground connection. Also, they didn't have screws down here. Look at that. So the idea is those goes in here and just hold the sides in. It's a little bit weird the way that this is assembled. Also, what I immediately saw is the different inner metal here is isolated, right? And this is the chassis, and this is also chassis shield and stuff. And the meter is really, really big. This is good for school use, so everybody can see what's going on. Now I am getting a little bit confused. If we look at the chassis again, what was it? So this is front, right? Okay, see? This is the side that's isolated. Okay, let's throw this away. So it's this side that is intentionally made to have good contact on the chassis or the lid. But look, it is isolated. Really? So what is the point? This is isolation. I don't get it. Why is this isolated from chassis and specially made to have good contact on the chassis? But the other side, that is definitely the frame here, and everything metal is connected to that. And that is connected to this. Everything here is connected. What is it? What was the point? But anyway, I'm trying to figure out how to pull this apart, because there got to be a way to do this, because we can't see what we're doing here. It looks like we got a magic trick down there, right? So here is a screw that goes through a hole. So the idea is you can lift this or do something. And it's the same in the other end here, by the way. So that is interesting. Why have we got 3 wires for the meter? That is also a little bit interesting. 2 ranges or something. What is going on here? So that is the power supply, and as we see up here, let's see if we can get some light. Here it says RV35 power supply, and then see this 63. That is 1963. The schematic was published in 1964, by the way. So that is the PCB layout, and this is the power pentode for the high voltage regulation. Here's the feedback amplifier, and this is the voltage regulator tube. So that is basically the circuit. As you see in the schematic, they're also using more modern bridge rectifiers, and that will be those. Isn't that just nice? No more tube rectifiers. Now we're in the modern world of diodes. Yeah, you can see them here, the yellow diodes. That is so nice. So I think the idea is we take away those screws and also screws in the bottom, so that means the bottom frame here will go away because that is in one piece, and then we should be able to see what is going on and also access the attenuator. And this is the bottom view, and again the 4 bottom screws, they are short, and the 4 top screws, they're also short, but at the back side we got some very long ones. So I got it right. This is the idea. So now we can see everything. This is something I need to clean. This, I think there's some chemical reaction to this kind of metal. I've seen this many times before. And yeah, we need some more. Oops, there's a missing screw. Oopsie doopsie, somebody was in here. This is of course something I can fix. And this is the back side of the power supply. Let's have a look. It is beautiful, this PCB layout. And look how they're connecting to ground wires here, and I mean, this is beautiful. This is definitely how you do that. Great. So that will be 3 tubes on the power supply. Yeah, and then 9 tubes in total. Yeah, that was very close to what I was thinking. We got a lot of gain stages. So like you see on the schematic, just a lot of gain. Beautiful. Mount this capacitor. Yeah, we got, I think it's 4 EF 184, yeah. There was another shield, and you can get access to all the adjustments from the side and from the bottom. And everything is nicely labeled. Right, this is polished aluminium. You can even see the marks from the machines. So beautiful. So this is the left side inner shield plate. Is this really necessary? You can imagine there's another side plate on here, and it is connected to the bottom here and all that, but even that, they mount this and put in 6 screws. Look at this, and that's because it's really difficult to lift up the lid. So I guess this plate should have been a little bit shorter, but then of course you would have damaged this feed through point, and this is maybe Teflon. And this looks like, what is that? You can see here the solderings. Is this a moisture damage, or is this just cleaning chemicals or something? It looks a little bit weird when I look at this. This is definitely the amplifier port, and it's also marked 64. No, this one was 64, right? And the other one was 63. Yeah, that is how it is. So they even made a little extra plate to hold the wires, hold this wire. Oops, a little holder here, and then the resistor here. And oh, so this is the high impedance input point, right? Teflon feed through. Don't even go to the PCB. No, there's a hole, so you can solder it directly to the grid of that tube. So this is the series resistor for the grid. That is beautifully made. Let's see the bottom. Let's see the input attenuator. Oh, there's another screw missing. Somebody was in here. This one is definitely not aluminium. This is super heavy. So this is steel. And we got all the resistors for the attenuators on a PCB. Yes, that's 10 dB attenuator. 0.2%. Isn't that right? Well, this is how you do it. That would have been expensive back in the good old days. So this is the input trimmer capacitor to trim the balance or for high speed. And there's another trimmer as well. So this is for calibration. This is something we can play with. And see what I'm saying? So this is the half. Yeah, that is what it is. This is the switch. Click. And then it goes easy, and then haha. So this is a factor of 1,000, I believe, right? Millivolts to volts. Punk. Yeah, I definitely feel that. See this shielding part of the metal here? That's what goes in here. So the mains switch is not radiating anything bad into this part. So probably this is what happens is you need better shielding here. And two of the screws they were missing, and this is maybe why this meter didn't show 0. Haha, this is something we need to look at. Of course, I'm going to try and clean the contacts here and clean the metal because it's a little bit dirty. So there's a little bit of a cleaning up here. See? This is not so good. Oh, yikes. So that was a tough job. I've been cleaning everything all the way around here, and all the feed throughs with cotton buds and alcohol. So it's all the way around here. Switches as well. So I think that I solved all the leakage, if there is any. Here's a better view of the rectifiers, by the way. A B500 and a B80 rectifier. Look at the wiring, how beautiful that is made. And the planning. See, this is the mains input, and then, oh, let's take the wire this way around to the switch and the bulb, and then back again to the voltage selector, fuse and transformator. It's just exactly how you do this the right way. perfect planning. I think you got to see this. So this is the power supply. It is using a very cool way to do this. The filament of the first 4 tubes, they're in series and they are running off regulated and filtered DC on the filaments. So the further you go to the more and more critical input, the more and more clean DC the filaments will have. Isn't that just amazing? Let's look at the schematic too and see how this is done on the first tubes. That is just fantastic good ideas. Very, very simple. And this is the adjustment. They call it adjustment 8, and this is of course to regulate to fine-tune the 250 volts. So I'm going to go through all this, starting of course from the voltage. So when this is fine-tuned, then I will go and adjust everything correctly.